In this video, we're going to be adding and subtracting rational expressions. So if we want to add or subtract fractions, the biggest thing you want to make sure is that we have common denominators. So here's a generic version. So we're going to be asking ourselves, what does the left denominator need? What does the right side have that the left side does not have? It has a D, so this needs a D, and the top and bottom need D. We end up multiplying there. What does the right side not have that the left side had? Well, the left side has a B, and so the right side needs a B, top and bottom. So when we multiply A and D together, and B and D together, C and B together, and D and B together. Now that we have the same denominator, we're allowed to rewrite it just using one of those denominators and combine our numerators. So AD plus CB. And in general, that's what we're going to be doing today, giving each of our fractions the same amount of denominator. And in order to do that, we also need to make sure we multiply the numerator by whatever we give it, and then we can add and subtract. So it seems easy enough. Let's see how we can complicate it here. Start off simple. We have a rational expression that looks like that, with a rational expression that looks like that. We check to make sure we have common denominators. We do. We can rewrite it using one denominator and combine our numerators. 4 plus 5 gives us 9. And then we need to reduce or simplify any farther if necessary, because 9 is really a 3 and a 3 being multiplied. Then we can factor out that 3, and then cancel our common factors, and we are left with 3 over x. Alright, let's do another one. Again, we'll have common denominators here. This time we'll be subtracting our expressions. We have a 2x minus 4. So again, because we have common denominators, we can rewrite it using one of those denominators and combine the top. So 2x minus 4. Now, see if we can cancel any common factors on top and bottom. 2 goes into both of these terms. So if we take a 2 out of each, we are left with x minus 2. We could distribute to check it. 2x minus 4, that's correct. For x minus 2, because we have common factors, let's get rid of them. And our simplified form is just 2. Okay, so those are common denominators. Now what happens if we have two expressions with uncommon denominators? This is where it starts to get tricky. 4x squared minus 12x over here. So in order to do this, you want to get factors in your denominators here and look for common factors, and then look for what's missing from each one. We want to give each of these denominators the same value. So in order to do that, let's factor. If you go down to prime factors, it makes it really nice and clear what is missing from each denominator. What do they both need here? So I'm going to give myself plenty of space. Let's factor out a 4 first. And then we would have, a 4x. My apologies. Both terms have a 4 and an x inside them, so we'll take that out. And that would leave us with an x minus 3. So if I rewrite that using only prime factors, we have 2 times 2 times x minus 3, that quantity. all over x, or all underneath x. So now, comparing these two lists, again, because we made a prime factor list, it's easy to compare. What does the right side have that the left does not? Well, it's got two 2's, and the left side only has one 2, so we're missing a 2, and an x minus 3. So that's what I need to multiply my top by, 2 and an x minus 3. So I gave the top and bottom what was missing there. Let's look on the right side. What does the left side have that the right side does not? So the left side has another x, two x's right here, and this only has one x, so we need another x here. The left side also has a 3 that the right side does not, so we're going to multiply top and bottom by 3x. That's what's missing there. So now we can rewrite this all using one denominator. What is all this as a denominator? 3 times 2, 6 times 2 is 12, and try that one more time. 12. We got x times x, that's x squared, and we have x minus 3. So that's our new common denominator. Let's combine all of our elements on top to give us a numerator here. So 5 times 2 is 10, and then we want to distribute that 10 to the x minus 3. So 10 times x is 10x, and 10 times negative 3 is negative 30. Come over here, we add a positive. We're going to add a positive 3x squared. So I'm going to put that at the front so that my polynomial is in order of powers here with the squared and then the 1 power and then the constant here. So 3x squared plus 10x minus 30 is our new numerator all over a common denominator of 12x squared times x minus 3. So that's about how complicated things can get. But again, if you break things down, if you break both denominators down into prime factor lists, it will help you easily visualize what is missing from each denominator, and then you can multiply top and bottom by that missing amount, and then just combine everything under that common denominator or over that common denominator, and then simplify any farther if necessary. So good luck adding and subtracting rational expressions.